Okay, so let's start. I'm going to present my screen. I'm going to present my screen. So now please reply with the voice because I will not able to see the chat box. So let's go for. In last session we talked about propositional logic. We discussed about what is the logic, how can we represent the logic. Let me go few slides before. We see entailment, that how can we prove that the things are true. We learn to write the proofs. Also we discussed three properties: soundness, completeness and consistency of a propositional logic. We also check that what are the issues or of the propositional logic, which are the propositional logic statement and which are not. We discussed about prepositional statements. We can write the atomic statements or complex statement by combining them with different symbols. Symbols like negation, and, or, implies, bidirectional implies, that is if and only if. Okay, so I hope you remember this. We will continue with that. The propositional logic we learn. What are the problems we are facing with propositional logic? First is prepositional logic can't predict anything. And second problem we discussed was statements having the words like some, every, all, anything, anyone. So how the propositional logic can express these things? Propositional logic don't have any way to express the things like some, all, every, anything. And because of these two issues, today we are going to learn the first order logic. First order logic. Okay, now how that will be helpful, that we will check, and how can these two problems, that the prediction and or some, every, all, these words we can express using logic, that we are going to learn. So are you ready for it? Give me quick reply so that we can start for first order logic. Yes, are you able to see my screen? Please
Yes, sir.
reply because I am not able to see the chat. Will
Yes,
someone?
sir.
Am I audible?
Yes, sir.
Does my voice is reaching to you? Sorry. Yes, does my voice is reaching to you?
Yes, sir.
Okay, okay. Sorry, I was on mute. So let's start with FOL. It is called as first order logic. Also, it is also called as first order predicate logic or predicate logic because it predict. It predict. We can bring the prediction in the programming, logic programming. So let's start what it can do. We can write predicates in FOL, like suppose we take an example, gorilla is black. Gorilla is black. So tell me it is true or false. Yes, can anyone tell me this is a true or false? Using propositional logic, we cannot express this English statement in propositional logic statement. I repeat, we cannot express this as a propositional logic statement. And that's why we are going to learn the FOL now, how the FOL will express this. Let's check. If X is gorilla, then X is black. If X is gorilla, then X is black. Like this logical statement in first order logic we can write. Let's check one more example. Okay, in this example, if you see, gorilla has a fixed meaning, so it is a constant. Black color, again, this is a constant. So this is one feature of FOL. You can use constant in this logic, which was not possible in propositional logic. Second example, let's check. Let's say John is smart. This is a statement, and we want to present this in a logical way. So it will be presented like this. Where John is a constant, smart. Now see, for a smart, what will be the value? We can't say. So this value will be variable. Please understand one more term, variable. So we can express this as John is smart, like this. John and in bracket smart. John is smart will be expressed like this. So FOL, we can talk about like a language which we are using for programming, which have a constant variables, and using these we can prepare the statements. We can prepare the statement like if then else. We can write the logic as our programming languages we are using to represent the logic. See, this is FOL is the FOL is actually the expressing the programming languages we are using. We will check few more examples. In these two, see this John, black, gorilla, these are the predicates. This one statement, gorilla, X is a gorilla, then X is a black. This is one predicate we have written. Or smart is a John, this is one predicate we have written. So understand what predicate is. FOL, we can write the predicates. Predicates are like this, first predicate and this is a second predicate. Every predicate is expressing some statement. Okay, let's go for a few more examples, then you will be more confident about it. Let's say example 3 is all boys like cricket. All boys like cricket. So how can this be expressed in FOL? Here predicate will be like, so please understand, it will be represented like boys like cricket. Boys like cricket. Okay, are you able to how to read this? This boys like cricket. This statement in predicate here like is a predicate which is expressing this. Actually, this total statement is a predicate. Boys like cricket. Let's see one more example. Some boys like cricket. In previous example, all boys like cricket, and now here I am talking about some boys like cricket. Now here also predicate will be like who likes the cricket? Boys like the cricket. So again we can write the FOL statement like boys like cricket. Do you understand now? How can we go for it? At least some confidence. Give me reply. Now see these predicates may be variables we can use. Symbols we will use to build a compound statement. But do you got the idea how can we write? Because see, logic means ultimately we are going to find out true or false. Correct? In first order logic, we can use constants and variables to write predicate. So that is more flexible to express our statements, English language statements. And the facts will be given in terms of predicates. Using those facts, we can apply the proofs. We can go for reduction. We can go for back chaining, resolution. By using those, we can once given facts are there, with the help of that, we can derive new facts, we can derive new proofs, we can derive new formulas or theorems. So that is our aim. Right now we are learning how to write the statements, but now if you observe, actually in English, definitely this question will be in your mind that first statement is all boys like cricket and second statement is some boys like cricket. But as a predicate logic we are getting, if you observe that, if I think that, see, boys is one set and cricket is another set. Boys is one set and cricket is another set. When I say all boys like cricket, then both the set will be superimposed within the same. Correct? So both set will be same. Even if say I will say that suppose cricket is another set and boys is another set, but this statement all boys like cricket making this set a single set, both representing each other. But if we talk about some boys like cricket, then it will be surely different. Boys set will be different, cricket set will be different, and this is the part of intersection, which is actually some boys like cricket. So see, FOL deal with the domains. From that domain, we can use constant variables or predicate to represent facts in that domain. Now here, boys is one domain, cricket is another domain, and facts, or we can write a predicate that boy like cricket. Boys like cricket. Sorry, yes should be there. Boys like cricket, like this. So actually, representation or even the statements are different, but we are getting the same predicate logic. So that is not more accurate. That is not more clear. So both predicates are same, which is not correct. Then what is the solution? See, in first order logic, we should able to represent all boys and some boys differently. Do you agree? both should not be same. So what is the solution? Are you getting me? What is the problem we are facing now? Please reply. Yes, are you there? Am I audible to you all?
Yes, sir.
Okay, so is there any confusion in your mind how I am writing this FOL? We have seen very less examples, I do understand, but at least whatever statements we have written, first two examples, gorilla is black, second John is smart, and these two examples. At least these examples, do you understand? We will check how to solve this problem. No reply means still you have some confusion in your mind. Okay, no worry. At least do you understand the problem here? Two different types of statements we are representing using same type of predicate statement. At least this you understand?
Yes, sir.
Okay, great. So how can we find the solution for this? And the solution is very important. That is a quantifiers. Remember this word, quantifiers. This is the very important point from first order logic. Now, quantifiers will be used when such all, some, every, anything, anywhere we have to represent. At that time, quantity, which are representing the quantity, it is all or some or every like this. So two quantifiers. See, this is the fourth term I am introducing. First term was constant, second was variable, third we talked about predicates, and now this is the fourth term I am introducing, that is the quantifiers. Quantifiers is the solution to predict clearly, like all and some should not be predicted same, should not be referred similarly. Okay, these two should not be same. That's why we are going to find the solution, and that is a quantifier. Let's talk what are the quantifiers. Two quantifiers are there. When I'm saying all boys like cricket, so first quantifier is universal quantifier, which is this opposite A is the notation for it. Universal quantifier, as the name universal, it represents all. It represents all. And second quantifier is existential quantifier, which is opposite of some symbol, which is for representing some. Okay, so we are going to rewrite example 3 and example 4 using these quantifiers, which will be now will make our predicate correct, accurate. So let's go for it. All boys like cricket. So please understand how the variables are used here and universal quantifier. All x such that if x is a boy, then x like cricket. I repeat again. For all x such that if x is a boy, this arrow means then, this is a if then, if x is a boy, then x likes cricket. This is the now correct predicate. To represent all boys like cricket. You may reply, do you understand all quantifier? Here x is a variable, boys likes are the predicate. We are passing some variable or constant. Cricket is a constant. We can pass some variable or constant to the predicate, and then predicate will tell true or false. Now, if x is a boy, then we can say that, say that x likes cricket, that boy like cricket, also true if x is true. This is the meaning. And all means what? All x means all boys will like the cricket. Like this we can represent it. Let's check for some. Example 4 was some boys like cricket. So instead of all, now we have to talk about some set, not a full set. So that will be, there are some x such that if x is a boy and x like cricket. So you can observe the difference. Here is the implies, which will talking about all the boys, but here those boys who like the cricket, means here is the existential quantifier some word will be represented by this. Note that here is the imply sign and here is the and sign. Take a look back half second how universal quantifier to be used and existential quantifier to be used. I can understand that this is the very first time you are going through it. So at the beginning, I can understand what is your mind situation. But at least now many questions might be in your mind. But please try to concentrate on these two examples, how they are represented. For all, how universal quantifier is used, and for some, how existential quantifier is used. Is it okay? Shall we move further? Is there any query in this? Please reply. Shall we continue, or you have any query in this quantifier? I'm waiting for your reply. Please, someone unmute and tell me what is the situation. Am I audible? Am I audible to you all? Or my voice is not reaching to you? Then why you are not replying? I don't know. Please, someone, whenever I will ask question, please someone respond with voice, because I'm in full screen mode. Okay, let move next then. Then now try to recollect with those four examples, which are the basic elements of first order logic. First order logic will have constants like 1, 2, A, B, C, D, some names, predicate like this. First order predicate logic will have variables, as we see in X, Y, Z, A, B. We can use the variable. That variable will get assigned some value. Yes, as per the logic. Then first order logic will have predicates like brother, father, like, boy, John, smart, like this, different predicates will be there. Ultimately, predicate means that will find true or false answer. Okay. Then we can use connectives like two FOL statements we can join with and, conjunction or disjunction, negation. This is implies if and only if, double arrow or single line, but sorry, double line or single line, but right side arrow. That is if this then that, like this, and this is if and only if, both side arrows. Fine. Again there is a equality element. We can show that two FOL statements are equal, and quantifiers as we seen all and some. So remember these basic elements of first order logic: constants, variables, predicates, connectives to form a compound statement, equality to check two statements are equal or not, does two statements are giving the same result, either true or false, predicate statements, and the quantifiers where we can represent a or all or some. So these are the examples now. We try to design for this so that you will be more confident. Now, few statements I have taken. Now we are going to try to write the first order logic statements for this. So let me go in paint mode. I will copy these statements in paint mode so that we together can try to design the FOL statements for this. So just a minute. I'm going to copy these statements in paint. We'll combinedly go for it, because I do understand what is your mind condition might be. Okay. Does my screen is visible? Does paint screen is visible? Now you can type in the chat box, no problem. Yes, please tell me. Is it visible? Okay. So let's start with the first statement. Ravi likes all kind of food. I'm going to write that statement again. Ravi likes all kind of food. Yes. I will help to go for first 1-2 statements. Ravi likes all kind of food. Yes. What is the predicate here? That we want to check. Now, as all word came here, we have to use which quantifier? All means, can anyone tell me which quantifier we should use? Two quantifiers we have seen, universal and existential. Yes, Parvez is saying correct, universal. So I will write all and the variable x, all x. Okay, such that this is x, all x. Sorry, let me take this all x such that yes, Ravi likes all kind of food. So we want to find out what Ravi likes. Correct. What Ravi likes and what it is? Food. And universal quantifier all is what? All Ravi or all food? All Ravi or all food? See here the predicates we can have. We can make Ravi as a predicate. We can make likes as a predicate. We can make food as a predicate. All kind of this will not be a predicate. So now we have three options. Then we have to check which we can plan. And yes, Parvez is saying food. All kind of food, not all Ravis. So all x I must have to represent to food because all kind of food. Correct. So I will write the statement all x such that if if sorry if x is a food, how can I write that? Like this. If x is a food, then if x is a food, then Ravi will like it. Do you agree? If x is a food, then Ravi will like it. So here likes will be the predicate. Who will like and what will like? That order you have to maintain. Ravi likes what? Food. So like this we can write the statement. Ravi likes food. If sorry here we are using the variable. So food will be represented using that variable which we are taking because all quantifier is using x to represent the food. So this will be the answer. This will be the statement which is talking about the statement Ravi like all kind of food. I repeat again, all is there, that's why universal quantifier. So all x such that if x is a food, then Ravi likes x. If x is not food, then Ravi will not like, because here the statement is saying about Ravi likes all kind of food only. So anything which is food, Ravi will like it. Yes, please tell me, do you find more compatible as compared to previous examples now? Give me reply. I am expecting the reply from all. Please give the reply so that I do understand you are here or not. How many students are attending? I should be able to understand. Okay, only Parvez is saying yes. What about others? Okay. Let's go for second statement. What is the second statement? Apple and chicken. I do understand now it's a time to go for a lunch after 1 hour, but please concentrate here, even though the words are there so spicy. Okay, apple and chicken are food. This is the English statement. We have to represent that using predicate. See, we have made that food as a one predicate. X is a food. So this statement, this is one logical statement. Food. X is a food. This is one logical statement, and it will represent either true or false. Either X will be food, true, or X will not be a food, false. Like that. Now here, apple and chicken are food. Apple and chicken are food. So here it will form two statements. Here it will form two statements. Two constants are going to be a food now. So again, my predicate will be food, and what I will check, apple. So this will be one statement. This will be one statement that apple is a food, and likewise I can say yes. Anyone? Similarly, what I can say, I can also say that another food is mentioned in this statement, chicken. Correct? Do you understand now how we can convert this into the predicate logic? Apple and chicken are food. Then apple is a food and chicken is a food. So from this first statement we got one predicate, but from this second statement we got two predicates. Feeling comfortable? Shall we move for the next statement? Shall we move for the next statement? Please reply. Okay, great. Now third statement is Ajay eats peanuts and still alive. Ajay eats peanuts and still alive. So let me write that statement. Ajay eats peanuts and still alive. Okay. How many statements are there in this? Actually, in English also, this is a compound statement. You will find that Ajay eats peanuts is one sentence, and Ajay is alive, still alive is another statement. Do you agree? Do you agree with this? It is actually a compound statement in English. Similarly, in FOL also we have to write the two statements, and we have to join them with conjunctives, connectives, and okay. So we try to write one by one. So can anyone try now for this statement? Ajay eats peanuts. Can anyone help me to write the predicate statement for this in FOL? Please try. Otherwise, I will not understand how much you are getting. Ajay eats peanuts. How it can be written? Can I make Ajay as a predicate, eats as a predicate, or peanuts as a predicate? It will tell true or false. What I can make? Predicate. Please try. Even if it is not correct, no worry. But eats. Okay, Kumar is saying eats. Any another option? Kumar share eats. Anyone else other than eats feel that it is a predicate? Okay. Great. Kumar is saying correct. Eats is the predicate, and it will have two variables, two values. Sorry, two values we have to pass. What are the values? How can we represent it? Who eats and what eats? Who eats, that we will write first. Ajay. Yes, and what it will eat, that we will write later. So this statement will say Ajay eats peanut. Ajay eats peanuts. Tell me, do you understand this? Tell me, do you understand this? Okay, great. Now we have to find out still alive for this still alive. So what do you think? This statement is representing what is alive? Is alive. What is alive? Peanut alive, eat alive, food alive, or Ajay alive? Yes, Ajay is alive. You are correct. So how I can represent that? how I can represent that using predicate. So Ajay will be predicate or alive will be predicate, which will read true or false. What will be predicate? You said correct. Ajay is alive. Yes. So alive will be the predicate, and to that we will pass a variable Ajay. So this will give true or false. Correct. So good. I hope you are understanding now. This first statement, Ajay eats peanuts, we written as Ajay eats peanuts, and still alive we written as Ajay alive. And now and, so we have the conjunction. We have the conjunction symbol, that is the and. So this is the final statement. Ajay eat peanuts and Ajay is alive. Correct? Correct? Shall we go for next statement? Shall we go for next statement? Any confusion in this? Do you understand this statement? Please reply so that we can go next. Replies are very less as actually. Others are just joined or they are understanding I'm not getting. Okay. Okay, go next now. Let's go for the statement number 4. Statement number 4 is anything anyone eats and is not killed is a food. Okay. Let me go for it. Anything, let me write that statement, statement number 4. Anything anyone anyone eats and is not killed is food. Okay, first of all, let's try to understand the meaning of this sentence. Then only we can write that in FOL. Yes, this sentence is talking about what? What is the message this sentence is giving? Do you understand? Read it. Try to find out the meaning. Anyone would like to try? Okay, let me tell you. What is food? What is food that is mentioned in this sentence? To what we can say as a food? Probably it is for a vegetarian people. This is a vegetarian definition. Anything anyone eats and is not killed is the food. Okay. See now, as a human being, can we able to map? Sorry, this is a spelling mistake. Let me correct it. Anything. Let me join it. Extremely sorry for this spelling mistake. Okay. Anything anyone eats. So can you tell me anything means what it is representing, and anyone means what it is representing for? Can anyone tell me? Anything. Please try to think. Anything and anyone. Anything represent to what and anyone represent to what. I hope now you might be understanding that how the natural language statements becomes more complex to understand, because it is they are taking the reference of previous word, previous sentence, accordingly to apply to the next sentence. Anything represents food. Neha is saying very good, you are correct. Anything represents food. Perfect, Prajita, Pravesh. And anyone represent the person. Very good, very good. So this is food and this is person. Correct. So do you understand now? Here we have to use two variables. One is for food and one is for person. Correct. Correct. We have to use two variables. So let go with person is X X variable represent person and food represent Y. I write that here. Anything means food and anyone means person. Is it clear to you all? Let try to write these sentences now. Now what are the sentences? Two sentences are there. Two sentences first. Which are those? Eats and not killed. Eats and not killed. If these two statements are true, then only the third statement, it is a food, will be true. Are you getting this? So total how many sentences are there? How many atomic I hope I am audible now. Am I audible now? Yes. My voice is okay. Okay, great. Sorry, there was a internet problem. Okay, let's continue. Here we are talking about three statements, if you can understand. One for eating, second for killed, and third which is the food. Okay, so here how can we write? Please concentrate for this example. We have to represent this. Anyone means all persons. So how can we represent all persons? With universal quantifier. Correct? All x. And again we have to use again one more universal quantifier for food. So that I will write all x and all y such that, please understand, we are going for more complex form now, such that if, now for eat, who eat what? Tell me, how can I write eats? Yes, what should I write in this bracket? Eats. Who eat what? Can anyone help me? Anyone, anything. So what should I write here in the bracket? You are correct, Parvez. What should I write here? Inside bracket, because we have defined two variables, x for anyone and y for food. X comma y. Correct? Do you all agree with Parvez? X eats y. Where x means we have x is we are representing for person and y we are representing for food. So x person eats y food. Do you understand this statement? Yes. Yes, do you understand? Okay, go. Let's go next. Now, this is a eats, not killed. Not killed means we have to write first killed. Killed as a killed as killed as one predicate. Tell me what variable we can send to this. Who can be killed? Now here you have to think about. Here you have to think broadly about this X can be a person or some animal like living thing, you can say any animal. Sorry, the spelling. Yes. So who can be killed? Food will be killed, or this anyone can be killed? Who can be killed? Yes, tell me. What should I write here? X or Y? Who can be killed? X or Y? X. Yes. Do you agree with Parvez? Parvez is saying X. Anyone feel that it is a Y? X is killed. But we want what? Not killed. So atomic sentence is this killed X. X is killed. But we want not killed. So what can I do for this? How can I make not killed? How can I make not killed? I have to use a symbol for negation. That is not killed. This symbol. Yes, negate. And it is a and here. Eat and not kill are joined with and. So I will write and. So let me read again. All such x, all y, such that x eats y and x is not killed. So anything everyone eats and is not killed is a food. Is means here we can represent that with if and else. Whatever we have written here, this is a if part. If it is true that x eats y and that x is not killed, then means this arrow, yes, and then what it is saying? It is a food. It is a food. So how can I write that in the predicate? Can anyone tell me? The predicate will be food. What should I pass to this? What should I pass to this? What will be the food? X or Y? Y. Correct? Correct. So this will be our statement. This statement is saying that all X and all Y such that X is Y and X is not killed, then Y is a food. The same statement in English can be represented using FOL here. Correct? Let's move next for next example. Next statement is Rita eats that Ajay eats. Yes. Rita eats that Ajay eats. Yes. Please, I expect now you should try for this. How can we represent this using FOL? How can we represent this using FOL? Try it. Anyone want to give some answer? I'm waiting for your reply. At least tell me what will be the predicate. Yes. Please try at least. Otherwise, it will be very difficult. Do we have to use any quantifier here? Do we have to use any quantifier here? See, what we want to say that something which Ajay eats, that Rita will eat. Something that Ajay will eat, that Rita will eat. But what it is all Ajay eats, that Rita eats, or suppose Ajay eats 5 types of different food, Rita eats all 5 or some of them. Tell me, what is the situation? If suppose Ajay eats 5 different types of food, then does all 5 Rita will eat or some of them Rita will eat? This sentence states. What does this sentence states? All 5, correct? Means we have to use universal quantifier. So Parvez was saying correct, I think. All quantifier I have to use. Let me write that. All x. Now here x will represent food, correct? X will represent food such that all x, such that if eats if Ajay eats X food, then yes, then Rita will also eat that food. Means Rita eats Rita. I want to make this capitalize Rita Y. Sorry, X is the food. If all such food X is represent all X such that if Ajay eats X, then Rita also will eat X. So this is the correct statement. Does this is a correct statement? Great, great. So see, this is the way which we can use to write the first order logic statements, FOL statements. Okay, first order logic statements. Any confusion in this? Do you have any query? Because now our next step will be we are going to write resolutions of predicate logic or FOL. Resolution means we by giving some facts, if suppose these facts are there, these facts are given, using these facts can we prove something, can we prove something. So for proving that we are going to learn in next session resolutions using FOL. We are going to prove something that will go in the next session. Any query for today's session? Any query for today's session? I will share in classroom today few statements. I will appeal you to write one statement group. I will ask to write the propositional logic and another for FOL, so that you will be more comfortable in writing FOL and preposition statement. Okay. So we will stop today. Thank you. Thank you.